Section 8.2 is on the area of the surface of revolution. So a surface of revolution is formed when a curve is rotated about a line. The same surface is the boundaries that we used for volume. Volume filled it in. Now we're just looking at going around the outside. An example of surface area would be the wrapping paper on a present, although that's got more surface area because you fold it and tape it and stuff. But if you think about the cylinder on the left for figure 1, if you think about it as a can of green beans, if you splice the label, if you cut the label down the side and laid it out, you would have this rectangle shape where the length is 2 pi r and the width is h. So the surface area of the label is, the area of the label is 2 pi r h, which is the surface area of the right circular cylinder. So if we were to take a cone like this and splice it and lay it out, we end up with this area of a sector of a circle. And we know that the area of a sector of a circle is 1/2 pi r squared h. So we can work with other shapes and use these formulas that we see. So here we have area equals 2 pi r L, where L is your slant height and R is the average radius of the band, and they work down and they come up with the formula down here at the bottom of this page, but you can kind of look through where it comes from, approximating the area and all of that. And we're going to look at it again on the next page. So here we have S equals 2 pi y, and then that's your arc length formula in there. That's your arc length formula, and this is when the top one is when you're working in terms of x, and the bottom one's when you're working in terms of y. And then they use these two formulas where ds equals L dx or dy. So it depends upon what you're working for. Oh, they labeled ds down here, and you can kind of see where the figures come from. So let's look at that a little bit better. So all of the other was concepts, but this is what it comes down to. This is your surface area formula, your area for the surface of a revolution. So you have 2 pi y, 1 plus dy over dx squared dx. And this is the second one is when you have your equation x equals g of y. So when your equation is x in terms of y, it comes from the formula of surface area, where the surface area is the integral from a to b of 2 pi times f of x times the square root of 1 plus f prime of x quantity squared dx. So that's where this comes from, and it's all based off of the 2 pi r h. So what you've got is you've got 2 pi, kind of your radius, 2 pi r, and your arc length is your h, or radius and height accordingly. Either way, let's look at an example. And it says the curve y equals the square root of 4 minus x squared when it's bounded between positive 1 and negative 1 is an arc of the circle, and it tells us that it comes from x squared plus y squared equals 4. Now you know that's a circle with a radius of 2, but we're cutting it off between 1 and negative 1. So let's look at that picture. So if we take that circle from here, we have a circle centered at 0, 0 with a radius of 2, and we bound it between negative 1 and 1 and rotate it around the x-axis. This is the figure we come up with. So the question is, find the area of the surface obtained by rotating the circle, this arc, about the x-axis. So it's a part of the circle which when you rotate it, it becomes a sphere. So we're going to use our arc length formula, and it says S equals the integration from negative 1 to 1, 2 pi y, the square root of the arc length, 1 plus dy over dx, quantity squared with respect to x. So that means I need to find the derivative first. So let's say y prime, let's rewrite it. Y is 4 minus x squared to the 1/2. So y prime is 1/2 times 4 minus x squared to the minus 1/2 times the derivative of negative x squared is negative 2x. So then we have half of negative 2 is negative 1x times 4 minus x squared to the minus 1/2. Let's go ahead and put that in the denominator. So let's say negative x over 4 minus x squared to the 1/2. We could say square root, but the next thing we're going to do is square it inside of our integrals, so let's not waste time with that. So now we have s equals the integration from negative 1 to 1, 2 pi, and it says y. Y is the square root of 4 minus x squared. And then we have the square root of 1 plus dy over dx in parentheses. So we have negative x over 4 minus x squared quantity to the 1/2 all squared dx. So now let's work with that inside square root, the second square root. The first one is just 4 minus x squared. It factors, but it doesn't factor into complete squares, so it's not really helpful. We have 1 plus negative x times negative x is x squared. And then the bottom, something to the 1/2 squared is something to the first. So we just have 4 minus x squared dx. Now, can you cancel like this? No, because of this 1 plus. Don't play that game. It's not correct. So s equals the integral from negative 1 to 1, 2 pi, the square root of 4 minus x squared, the square root of common denominators, 4 minus x squared plus 4 minus x squared. So what you write on the bottom, you also write on the top. Pause and think about that for a minute. If you don't understand it, just pause it and think about it because it makes sense. When you put 4 minus x squared on the bottom, you have to also write 4 minus x squared on the top in place of this 1. So that's what's going on there. So we have s equals negative 1 to 1, 2 pi, the square root of 4 minus x squared. And here I have the square root of 4 minus x squared as my common denominator. So in the top we have 4 minus x squared plus x squared, which is just 4. Now these could cancel. Let's write it in a way that you'll see it. So we have 2 pi, the square root of 4 minus x squared. Now that we have the common denominator and there's only one fraction, we can split the square roots into 2 parts. Because it is true that you can go from one of these to the other. Now these cancel. Do you see that happening correctly at this time? So now we have s equals from negative 1 to 1, 2 pi times, and the square root of 4 is 2 with respect to x. So we have from negative 1 to 1, 4 pi with respect to x. Now when we integrate 4 pi, there is no x there. It's a constant, so we end up with 4 pi x from negative 1 to 1. So this means I have 4 pi times 1 minus 4 pi times negative 1, which gives me 4 pi plus 4 pi, which is 8 pi for our arc length, for our surface area of the solid. We did this one in terms of x. Let's look at one in terms of y. So the problem says y equals 1/3 x to the 3/2, and we're bounded x is between 0 and 12, and it says that we're rotating about the y-axis. Since we're going about the x-axis, what this means is instead of using 2 pi y, we'll use 2 pi x. So we say S equals the integration from A to B, and we would have 2 pi x, because x is our length from our axis to our curve at any point. And then we have the square root of, we're still in terms of y, we have 1 plus dy over dx quantity squared with respect to x. So that'll be a little helpful there. So let's take our y. So we have y equals 1/3 x to the 3/2. So y prime is 1/3 times 3/2 x to the 1/2. So that gives us 1/2 x to the 1/2. So now let's say s equals the integration from x goes from 0 to 12, 2 pi. Now notice this is dx, so we're going to keep the x. 2 pi x square root of 1 plus, and y is 1/2 times x to the 1/2, or the square root of x. You have to decide when whatever works best for you. And we're integrating with respect to x. So we have 0 to 12, 2 pi x, and we have the the radical 1 plus 1/2 times 1/2 is 1/4, and here we have x dx. Now we've learned that common denominators are helpful often. So let's try common denominators. We're going from 0 to 12, 2 pi x, the square root of, this will be 4 over 4, plus x over 4. So we have the integration from 0 to 12, 2 pi x times the square root of 4 plus x all over 4 dx. Now there's several ways to talk about this next step. Let's factor the 1/4 out like we did earlier. So we have 4 plus x here dx. So then we can take the square root of 1/4 to be 1/2. So we have 2 pi x times 1/2 times the square root of 4 plus x dx. And half of 2 is 1. So we can say pi x times the square root of 4 plus x dx. Now we've done all the simplifying we can do. So our next step is to try u sub, because remember that's our first technique of integration. So let's let u equal 4 plus x and du equals dx. Now that takes care of this part, but that doesn't handle this out here. So we're going to have to say x equals u minus 4. So we say the integral from 0 to 12. I keep losing that 1 on the 12. In my head, it needs to be a 2. So the integral from 0 to 12, and we have pi, and x becomes u minus 4, and then we have u to the 1/2 du. Notice that it's all u's. You can't have partly u's and partly x's. So we have 0 to 12. Let's distribute both of those. Oh no, let's keep the pi out here. So we have u to the 3/2 minus 4u to the 1/2 du. Now notice we can't integrate this term by term because there is no product rule in integration. It's called integration by parts. So now we bring down the pi. We integrate u to the 3/2 and we get u to the 5/2, and the coefficient is 2/5. Minus, we integrate u to the 1/2, we get u to the 3/2, and the coefficient is times 2/3 from 0 to 12. So we have pi times 2/5 u to the 5/2 minus 8/3 u to the 3/2 from 0 to 12. So we need to plug u back in. Remember that u is 4 plus x. So we have pi times 2/5 times 4 plus x to the 5/2 minus 8/3 times 4 plus x to the 3 halves from 0 to 12. That 8/3 looks really bad. All right, so when we plug in 12, we have 2/5, and 12 plus 4 is 16 to the 5 halves. So let's say times 16 to the 5 halves minus 8/3 times 16 to the 3 halves minus, and here we have 2/5, and 4 plus 0 is 4 to the 5 halves minus 8/3 times 4 to the 3 halves. Now that pi gets distributed by everything, that's why I did that. So we have 2/5 times, the square root of 16 is 4 to the 5th power is 1024 minus 8/3, and the square root of 16 again, remember this 2 means square root. The square root of 16 is 4 to the 3rd power is 64 minus, we're going to distribute this negative, 2/5 times, now the square root of 4 is 2 to the 5th power is 32 plus 8/3 times the square root of 4 is 2 to the 3rd power is 8. So we have 2048 over 5 minus 512 over 3 minus 64 over 5 plus 64 over 3. So run through those numbers real quick. I'm a fractions girl, so common denominators work for me, but whatever works for you. And I have 3712 over 15 times pi. So that is this exact surface area of the curve. So I think you've got everything you need to do this section. And thank you and have a great day.